next month, we will be talking about my favorite subject, which is machine learning and Go. Basically, I like Go, and I like doing machine learning in Go. So you should all come talk about it, because it'll actually be a really interesting discussion about kind of like the future of machine learning in other languages that are Python in general. So, yeah, we've got that next month, and then we got another one the month after that. So it looks like we are gonna start ramping these up again, and hopefully be able to have some good content for you guys. By way of reminder, this meetup is sponsored by the Forge Foundation. I have a link for the Slack in the chat. Feel free to join our Slack group. We do have some really great stuff going on in there. A lot of engineering talk, a little bit of machine learning talk. I always want to have more people to talk to about machine learning and data science and all that jazz. So feel free to join that and hit me up. So without further ado, I think we should turn the time over to Nelson. He has spoken at this meetup before, and it was awesome. And I'm really excited about today because I've been interested in Metaflow for a while, and so I'm really excited to hear what he has to talk about it. So I'll let you go ahead and introduce yourself, Nelson, and say any other speeches you want, and time's basically yours.
All right, great, thank you. I will just start by introducing myself real quick. My name's Nelson Griffiths. I work currently as a data scientist at Branded Entertainment Network, more easily known as Ben. So that is currently what I do. About in January, I think, as a data science team at Ben, we decided, well, I guess we were looking for some better ways to set up our machine learning infrastructure. And we came across Metaflow, and it has been awesome, which is kind of what inspired this current topic. So as far as presenting, I prefer it a little more casual. So feel free to interrupt me with any questions that you have, or you can shoot them in the chat or however you want. So 1 second, let me pull up my presentation and we will go ahead and get started. Let's see. All right. I hope you guys can see my screen now. All right.
We can. You're good.
Okay, great. That was what I was hoping. All right, so full stack data science with Metaflow. So what I hope to accomplish in this presentation, I want to give everyone a brief overview of what Metaflow is and how it works and what its purpose is. It's a library that Netflix open sourced pretty recently that basically covers a lot of things that have to do with machine learning infrastructure. So we're going to do a high-level overview of what it is, its purpose, and some of its features. Then I want to get into more of ideas that we have seen at Ben that help improve both individual workflows and team workflows when building out machine learning pipelines and systems. And along with a little bit of code examples of how Metaflow touches all of the parts of data science, the full stack idea. So what I'm not going to do is go really deep into Metaflow and how it works and how you write code with it and every single feature and how you would deploy something with Metaflow. And the big reason that I'm not going to do this is because Metaflow is probably one of the most well-documented libraries that I've ever seen. So if you want to see all of their tutorials and examples and instructions and learn everything there is to know about Metaflow, just check out the website. It's just metaflow.org, and you can click on documentation and go through everything. So it's super well documented, and I am not going to take a super deep dive into every little piece of it today. So we're going to focus more on high level, how is it useful, and why you might want to consider using it for your own projects or in your teams. All right, so what is Metaflow? We're actually going to start with why for Metaflow. Oh, let's see. Here we go. So the why of Metaflow. So this is actually just the Metaflow website right here. They put together a nice little why for Metaflow that we're just going to go through. So here is a data scientist. Data scientists solve important business problems. A good way to start solving a problem is to prototype a solution in a notebook. There are lots of great libraries available for machine learning that make prototyping fun. After the first experiments, it's a good idea to start keeping track of models and data. It can take a lot of work to get the latest data and keep the models up to date reliably. Production workflows should run on servers, not your laptop. These days, servers execute containers. Workflows need to be packaged for execution. Where should the results go? Sometimes they are deployed as containers too. Containerized models can be consumed by business applications. Stakeholders evaluate the results. They want more models and better models. Taking care of all of this can be hard. Metaflow can help. All right. So as data scientists a lot, at least in my experience, the fun part of data science is opening a Jupyter notebook, taking some data, building out a machine learning model, figuring out how to get it to make predictions in a way that you want, and experimenting with more of the sciencey part of it. It is much less interesting to figure out how you need to deploy that model, how that should be in front of whoever your audience should be. It's not super fun to maintain the model or the code. Those things are much less fun, as it kind of showed in their little why. And so Metaflow is a library that was written to help make all of these things a lot easier. So I stole this little screenshot from Metaflow's website also, which shows the setup of Metaflow. So the general idea of Metaflow is that you should be able to write any pipeline that you have as what they call a flow, which is really just a DAG, or a directed acyclical graph. Really, it's just you run something, and then you run the next something, and the next something. The idea is that it should just be set up nice and simple as a flow for you to run. So on this screen, the main idea of Metaflow is right here on the flow. So you write a flow, which is usually just a Python script. In this flow, you build this graph, which is just a lot of steps linked together. So for example, a flow for a machine learning pipeline might look something like a step where you pull in all of your data, a step where you process your data and create features, a step where you train your model, a step where you evaluate your model, and then you're done. And the idea is that Metaflow should make all of this really easy, and make it so data scientists can focus more on building models and less on what happens after you build a model. So we'll come back to this diagram in a second. But first I want to show you basically how it looks in code. So Metaflow is set up so this flow is a class. So here you have a class that inherits flow spec, and that's just saying this is our flow. And they make it nice and easy, so you have a step decorator, which tells you what a step is, and then you just write a function, and that is your step. So as far as how Metaflow is written, it's pretty flexible, and it's just written with code and decorators. So here I put together this practice flow is what I call it. And just to give you an idea of what we're looking at, each step here is just a part of the flow. So the flow starts, and then it goes to this next create data step, creates some data, splits off into 2 different steps at the same time, so it runs in parallel. These both go into the combined stat step, and so on and so forth, on down the line. So it creates this nice graph that runs things in the order you tell it to, and it's nice and pretty. So how does that help with all of the not fun stuff that data scientists have to deal with to make their machine learning models useful? Let's look at some of these features. So reproducibility. In the little Y of Metaflow, we saw that one of the things that we have to deal with as data scientists is some sort of containerizing of our workflows so that they can be deployed somewhere, that people always have the right versions of packages so that things don't break. One of the really nice functions of Metaflow is that for a flow, it creates a Conda environment where you specify the versions of all the libraries that you need so that someone else could run your code just installing Metaflow and the flow will work because it takes care of all of that containerizing and making sure that your libraries are the right versions and all of that. Another super nice thing that we're going to talk a lot more about is that it tracks all of the artifacts in the code. So when you write a flow, all the data that you put into it, the models you build, all of that is tracked forever over time. So you can go back and say, oh, when I ran this last Tuesday, this is what the data looked like. This was the model. These were the parameters. Anything that you're interested in, you can go back and look at because it tracks all of that. And then it also tracks the metadata. So Metaflow aims to make everything perfectly reproducible. And it does a very good job of it. Another really nice thing is scalability. So this is addressing more of the idea that you can't run production code on your laptop, or I guess you could, you shouldn't, for most cases. So 2 things that stick out about Metaflow for scalability is that first is that it allows you to scale your code as far as parallelizing things. You can run multiple steps in parallel, so you can be creating a bunch of different features at once or training different models at once or whatever steps you need to run in parallel. It makes it extremely easy. The other super convenient thing about Metaflow is that it integrates extremely well with AWS, due probably to Netflix's awesome partnership with AWS. But what it does is it allows you to run any steps you want in the cloud using as much CPU or GPU compute power as you want. So it makes it really easy to scale. And when it comes time to put something into production, you can make sure that your code is always just using the resources that it needs.
Hey, Nelson?
Yeah.
Does that mean like you can do just even like in your discovery stuff, you can be doing all of that basically on the cloud or on a VM?
Yeah, you can. So the way it works is basically Metaflow runs with decorators. They have a decorator that you just put by a step that says, for this one step, I want to use a 32 CPU machine on AWS and train this model, or I need 4 GPUs for this one step. And as long as so they have really nice instructions how to set up with AWS on their website. But once you set up with AWS, you can use whatever compute you want for whichever steps you want. And it makes it really nice and easy and convenient.
I don't know how familiar you are with Kubernetes, but to me that sounds a lot like how you allocate resources when you're defining your Kubernetes cluster. So that sounds real nice.
Yeah. Yeah, it is pretty convenient. Yeah. All right. Okay, so that was like the quick shotgun, some nice things about Metaflow. If it didn't make a lot of sense, bear with me for a quick second. We're going to go into some more concrete examples about how some of these things work and how they help you. So first, I just want to address this idea of full stack data science. So when I think of full stack data science, I think of owning the process of whatever you're doing, all the way from data to building a model to deploying that model and keeping track of what happens to it. So Metaflow makes a lot of these things a lot easier because, like I said, a lot of what the data science idea is those second and third steps, exploring the data and building a model, which are the fun and easier steps I guess for most data scientists, not for everyone. But Metaflow as a tool makes a lot of these things a lot easier. So we're going to take a look into how that happens. So I wrote a quick little flow, a practice flow, that I just want to introduce you guys to. And so it's not super important, all the code. If people are interested in looking at this later, I'm happy to share it. It doesn't really do anything. But I just want to walk you through the steps real quick so everyone knows what we're looking at. So we define a flow here that does just a few simple things. So we start the flow, and we go here and we go to this create data step, where we create two NumPy matrices that are just random numbers and a list of names. So we're creating some data. We calculate the means and the sums of the NumPy matrices. We count the letters in each name. We do some matrix multiplication, and then we're done. So basically just build some numbers, matrices, and does some basic functions to them. So this is the flow that we are going to be exploring a little bit for some of these examples. So let's start with the beginning of the process, data. So sometimes, depending on a team's workflow, you have a nice CSV that has your data in it, and you can just load that in, and that is all great and dandy, and it's super convenient. Sometimes, though, to get your data, you need to pull it from a database, and that can be time-consuming, or you might need to change things over time, what you're pulling. So one really nice thing about Metaflow is how we talked about it tracks artifacts. So if you are working in notebooks, you could write a flow that pulls the data for you, and that is it. And then from your notebook, you can access that data, and instead of taking half an hour to pull the data in case your notebook crashes or something, because that's happened to all of us. Jupyter is a little bit sketchy sometimes. But instead of waiting that 30 minutes every time you need to repull the data, you can make sure you access the data through what was stored by Metaflow. So let's look at an example. I have a notebook up here where we're looking at the practice flow. So here we can see all of these things. This is a list of all the artifacts that we tracked for the flow. So if I were, let's say this fake data was my data set that I just pulled from a SQL database, it takes about 2 seconds to get that instead of however long it might have taken to pull all the data from a database. So that makes it super easy to get your data once, never worry about it again, not worry about the database changing or more data being added or anything like that. So you can just pull your data once, start exploring, do whatever you need to do in the notebook to start building your model for your process.
Is there a version associated with that pull?
Sorry, can you explain that question a little more?
You mentioned an idea of versioning, so the idea that that data like, to me, you described that data as a snapshot or a point in time. I'm
Yeah.
saying, is there like an ID associated with that point in time or a version?
Oh, yeah. So a flow, the way that Metaflow is structured, it has a flow, which is the whole graph that you built. And each time you run that flow, they call it a run. So we can print a list of, let's see if that's right. Yeah, so here you can see I've run this 3 different times. So each one's just assigned this ID at the end, 1590, 1589, 1588. And you can grab whichever one of those you want. I just grabbed the most recent one, just
Cool.
to show you the data. But yes, they store all the metadata, so you can look back at when you ran it, how long it took to run, and you can select it in different ways. And we will look at a few of those ways in a second. But yes, everything is labeled and snapshotted, so you know exactly what you're looking at.
Awesome.
Yep, so you could even do something like if you're pulling from different sources or trying different data, you could have 3 different flows where you're getting different things and access all of them from the notebook just by selecting which run you're grabbing from, something like that. But yeah, so it makes tracking data over time super easy, which can be helpful at the beginning of a process when you're exploring the data. Yeah. So from here, we get into the fun part of data science, modeling. And these are actually 2 of the harder parts, I think, of building models that I have here, tracking your experiments and collaborating on projects with other people. So we'll start by talking about tracking your experiments. I don't know what everyone's experience here is with tracking your experiences while building models. I will admit that my process before was less than reproducible. I would try a lot of different things, and when I finally found something that I thought was the best, I just left the rest of my stuff in a jumble in a notebook and took that one thing that worked and brought it into whatever I was going to turn into production code, which is great if okay, it's just not that great, but there are better ways that we can track experiments and keep notes so that when people come back to the projects in the future, they have a history of what you've worked on, so you have a history of what you've worked on, and you can compare different things. So one of the benefits of Metaflow is that it makes tracking experiments pretty easy. One way that this happens is from what we already talked about, that it tracks data. So you can make sure that every single experiment you run pulls the exact same data every time. You can do this because Metaflow lets you access previous runs in current runs. So you could do something where every time you want to run an experiment, you pass some sort of parameter to your thing that says experiment, and then it knows that if it's an experiment, it should pull the data from run 1589 or something like that. So that every experiment you do, you can make sure that you're using the exact same data, and you don't have slightly more data or slightly updated data for a different model that you are experimenting with. Another thing that is super nice, if we look here, so let's come down here. So Metaflow also lets you tag runs, and this is a way that they have of organizing different things. So they use namespaces, which is just whatever the group of runs you want to access is under. And so when you run a flow, it automatically puts it under your own namespace, whatever your name is. So my namespace is just Griffiths. And every time I run something, it goes under that namespace. It also, though, will go under any namespace that I tag it under. So we here can look at namespace for experiment and then print the results from every single experiment run that I did. So here I ran 3 different experiments and told it that the result was different every time. So this could be like, we could be looking at maybe the MAE for 3 different type of models we ran on the same data, so that you can track over time how models performed on data with which hyperparameters. And it's a really easy way of tracking experiments. So if we go to our, where am I going? Go to our code here. We can run this really quick. Oops. We'll tell it the result this time is going to be 5. And then we just do this tag experiment. So this will run in about a minute or 2. We'll come back to that. But you can see that over time, it's really easy to look at everything that you tagged as an experiment to make sure that you are not losing any of the information that you have gained through all of the different things you've tried. And so Netflix, I know, really likes to use notebooks. I'm pretty sure they use standardized notebooks. And that's a great way to track this sort of stuff. We've also found that Streamlit apps are really good for tracking experiments and looking at the results of all of these different models. So this is just one way, that the artifact tracking in Metaflow can make sure that you're organized when you're doing your experiments and actually keeping track of what you're doing. Okay, that's going to take a second. We'll come back to that in a second. So the other thing here is collaborating on a project with someone else. This isn't a big deal if you work alone a lot because it's easy to keep track of what you do. What's a lot more difficult is when you and someone else are working on the same project at the same time. Then it gets a little trickier to figure out what's going on, who's working on what, things like that. So the way Netflix organizes these with namespaces and tags also makes this a lot easier. Oops. So here, if we look at, let's go to my namespace. Oops. That's not even my namespace. All right. I don't know what my namespace is. We're just going to go a list of all of the times this has been run. So these are all of the runs that have been done for this flow ever. So I work with Brad, who is another data scientist, and we collaborate on projects sometimes. He was nice enough to run this for me once. So if I go to his namespace, I can see all the flows that he's run. And we can see that he ran this practice flow 1 time. So this is really nice when you are both working on different features or different models and running experiments at the same time, because then you can both tag whatever you're doing as either feature creation or experiment or anything like that. And it's really easy to share results because I don't have to have him push something to Git and then pull it and then run it myself to see what he did, or hope that he sends me a Slack message when he found something cool. The second he runs one of these flows, I have access to it by either looking at his namespace or something we agreed to tag our experiments, or I can look at some other sort of tag. But it makes collaborating much easier because now you can see all the results that someone else is working on without worrying about all of the messiness of pushing and pulling and branches while you're just experimenting and trying to get something going. All right, so we came over here, this finished running. So now if we go back and we load our flow again and we look at our experiments, you can see our most recent result here was 5. So it added it to the experiment namespace and we can compare it to all of our other experiments. All right, so those are some of the benefits of Metaflow as far as the modeling part of the data science stack is concerned. So deploying models. So this is not my specialty. We have an awesome team of engineers that do a lot for the data scientists at Ben. But what I can speak to is how Metaflow has made their lives easier. So we already mentioned this, but everything is basically containerized when you run something with Metaflow because it tracks all of the packages you need, all the libraries. Everything is packaged nice and neatly. The other really good benefit that doesn't seem like that big of a deal, but has actually made a huge difference is that when you are writing everything using Metaflow, everyone that's writing code is following the exact same format. So you know that everything will be written in the same structure as a flow. And when you're deploying models, this makes everything super easy to just plug and play. So our engineers have built some nice tools that we can just push flows into and get them running in a production environment. I know Netflix is at least working on open sourcing something that you can run Metaflow with AWS step functions. And I don't quite remember what they do in-house. It might be Kubernetes. But when everything's packaged so nicely with Metaflow, the actual deployment of the model gets much more simple than worrying about all these different Docker containers and code being in different formats and what does it need as an input and output and all that. So it makes deploying models a lot easier. And then you need to use whatever that deployment outputs for other processes, whether that's to serve it up to a user or pass it into some other process. It's important to have an easy way of getting the results and getting them into whatever other environment you need them in. And once again, this is easy because of the artifacts that are tracked. So anytime you run that flow, if our flow is making a prediction, you can just go access those predictions from the artifacts of that run and then pass them to whatever app or user interface that you need them, which makes it super convenient. We also do this with tags. We have some tags that we use for models that are running in a deployed state so that people can run the flow and do their own thing and not mess up predictions that are getting passed to other people. But the apps are able still to just pull whatever is most recent from the deployed models and use them in whatever environment they're needed.
Hey, Nelson, there are some questions in the chat. Would you mind speaking to them?
I would love to. Sorry, I didn't see the chat up because it doesn't show up when my screen is.
Yeah, no, you're fine.
All right, yeah, let's go through these real quick. We'll take a pause. So Griffin asks if everything is tracked by default. So the answer is no to that. The way it's written, so here in the code, anytime so you make something an instance of the class, so self.mean1, that means it's tracked. If I would have done just mean1, now this is not something that is tracked. So you can just tell Metaflow what to track by making it an instance of the class. So if you're creating huge data and you don't want it to be tracked, it's very easy just to not track that. But yeah, so you just select in that way what should be tracked. Did that answer your question, Griffin? Great. All right, so can the flow be resumed from a particular position like modeling so that all previous steps need not run again? The answer is yes. This is, it looks like Savin answered these questions also, but I will go ahead and just do a quick demo of that. So if you pull the data once and you don't want to run that step again because it is time consuming or you don't want it to change. So here, combine stats. If you just do something like, let's see, instead of saying run here, we can just do resume. And then if you just do resume, it stops wherever the flow last ended. So since this ran all the way through, it will just run the exact same flow without running the steps, if that makes sense. It'll just copy all the artifacts again and count it as a new run. If you want to run it, or if you failed your last flow, so let's say it broke at combined stats, then I hit resume, it would start from combined stats. And I could go change my code, fix whatever bug was there, and then just start from combined stats again. Or you have the choice of just telling it which step to start from. So if we just do resume combined stats, you'll see it's going to resume the run. And then it'll start copying data from previous steps instead of running them. Takes a second. All right, we'll come back to that in a second after it's run. But yeah, it resumes, which is both nice for in case you just want to change the model every time and not run the whole flow, or for debugging. If you made it through some compute-intensive steps that you don't want to rerun, but then something breaks, you can change the code and only rerun what was broken. So it continues. So those are both really nice features. And I'll just say one more time, Metaflow has a lot of really cool features that I'm not even touching on in this presentation. So going and checking it out on their website and going through their documentation and all of their tutorials, which are super awesome, is probably the best way to learn all of the nuances of Metaflow. I'm hopefully just giving you guys some ideas of how this can be integrated into your workflow. Cool. All right, we will keep going. Yeah, so the other, as far as tracking model results, one big thing also with machine learning is that you want to make sure that your models continue to work as you retrain them, that they're not drifting or performing poorly over time. And these artifacts are also a really great way to do that. I've mentioned this, but we really like Streamlit apps at Ben. So when you have all of these artifacts, it's really easy to build a Streamlit app that over time will just show you the performance of the model as it compares to past runs. So every time you retrain it, you can see how it compares to the previous retraining, or each time it makes predictions, see how that works. So that is another really useful feature. All right, so that was my presentation. That was hopefully a good look into how Metaflow and some of the tools it provides can help you in each different part of that full stack data science process, from pulling data to modeling, deploying, and tracking the results of that. So are there any other questions? Cool. Griffin said he's going to start trying to use it at Qualtrics. Love it. I will say that as far as using it in a team environment, the learning curve, it was pretty quick to learn for everyone. Like I said, the documentation's great. And I think the benefits of using it as a team are much more powerful than just using it by yourself for personal projects. Yeah.
I have a question.
Yeah.
I'll probably, if nobody else has questions, I have a bunch.
All right.
But I want people to also ask their questions. So, oh, look, we got a question in the chat.
Would you use it for regression testing? By regression testing, do you mean testing different regression models? I'm going to maybe assume yes. If I'm wrong, go ahead and send another message. But yeah, we we use this a lot to test different regression models. So we will build out a pipeline that pulls data, and then we'll do a little bit of initial exploration in notebooks and building some basic models. Once we have some basic features down and we have a place where we want to start tracking what we're doing, we will test both different features and a lot of different models in Metaflow as we track them. And we usually do something where we have a notebook where we have a data frame that gives a little, we give it a description for what each model is. We show what features it's using, and then show some basic metrics like MAE. Oh, sorry. No, like regression testing to maintain model quality over time. Okay, yeah. So that's kind of the last thing that I touched on. We pull out artifacts from Metaflow a lot and plot like different metrics over time for that model. So when a model's in production, we can pull all of the artifacts from its runs. And we have Streamlit apps that we can look at each model in. And it shows if the model is performing well or if it's sliding and stopped performing as well, and we need to either retrain it or go and look at the features we're using or the data quality and check on it. So we actually really like using it for that. Hopefully that answered the question.
Okay, I have a question now.
All right.
Have you, well, and anybody can answer this as well. Have you used any other DAG engines like Argo or Airflow? And what's your experience with them as compared to Metaflow?
That is a good question. I personally have not. What I can say is that our engineering team, our data engineering team, used to use Airflow, and they preferred this times like 100 over it.
Well, if it's if
sorry,
you guys are on Kubernetes, that makes sense to me.
Yeah, they just, from what I understood, they thought this was much simpler, and also it had benefits both for the data science and engineering side, where Airflow didn't really do much for the data scientist. So I can't speak to that a lot, but that is just what I have heard from our engineering team.
Cool. Well, if I know that I have looked at Argo has a DAG engine as part of their deployment onto Kubernetes, but I think it would mirror Airflow a little bit more. So if you can, if you think that there's if Metaflow has a lot of benefits for the data scientists as opposed to just the engineering side, that's good feedback for me.
Yeah, I definitely think so. As a data scientist, I love using Metaflow for a lot of the reasons that I talked about, mostly like experiment tracking and tracking models after they're deployed. But I know our engineering team was ecstatic when they found out we wanted to try some of that stuff. So, yeah.
Awesome. Okay, that was my big question.
Cool. Are there any other questions?
Cool. Well, we'll have our fake claps, right? In-person meetups, you have a round of applause. I need a round of applause soundtrack to play after talks. I feel like we need that. But yeah, thank you so much.